Hi, we're Timeplast, a nanotechnology company that successfully solves the second biggest problem humanity has, plastic pollution. For this demonstration, we're going to take a regular water bottle, and Manuel is going to take the cap, which is a 100% fossil-based polyethylene plastic. He is going to cut it up. And now he's going to put it in with our additive. We are going to disintegrate the cap down to a molecular level and convert it into a wax-light, carbon-based, benign, biodegradable substance which is not harmful to the environment. At this point, I'm going to turn it over to Manuel, our inventor, for him to give you a more formal presentation and explain exactly what our product does.
Okay, thank you, Jorge. Timeplast received a patent from the U.S. Patent Office on December of 2015. About the technology, Timeplast is the first and only patented and proven nanotechnology that completely degrades fossil-based plastic after its desired use. A plastic treated with our technology only requires a very low proportion in mass to alter its physical stability, which then converts it into a safe, susceptible to degradation type of product. This process is achievable through an encapsulated solvent at a molecular level that targets the links in the polymer chain. So we manufacture and sell a degradant polymer which can be used as an additive to introduce a molecular disintegration process that activates at a programmable time on any fossil-based polymer chain. A single pound of our additive alters 100 pounds of plastic. We ship the additive in pellet form. Green labels can be introduced in any plastic product right after the formation process with our additive. We hold the legal and scientific rights to back that affirmation. So let's look at our published patent. One of the great highlights on the patent, and I quote, "Several formulations for environmental friendly compositions have been created in the past. None of them, however, decomposes the current polymer links between monomers and subsequently supplant them for weaker limbs susceptible to degradation. None of them include a polymerization process that opens the time window for nanoprogrammable matter to catalyze the needed reaction to reassign the length structure on the plastics, including oil-derived high-density plastics, without compromising its thermostability, thermoplasticity, physical, mechanical, chemical stability, and quality overall standards." Let's look at another highlight of our patent. I quote, "Yoshida oxygenation of bisphenol A to quinones by polyphenol oxidase." In other words, Yoshida studies show how an effective way to get rid of BPA or bisphenol A is through the use of polyphenol oxidase, which is one of the main components of our additive. This means that if we treat a plastic with our additive, we can get a BPA-free product after the formation process. To understand and to provide context to our technology, let me just say that plastic, as everybody knows, is the best material humans have ever invented. It's low cost, lightweight, strong, versatile, it has a very good quality, and it's durable. That's why our society is based on it. However, because of the fact that the earth cannot digest it, It has become the number one problem for human sustainability in terms of waste management and the second biggest problem humanity has. Every bit of plastic that has ever been created still exists. Plastic ends in the landfills and in the oceans. Just in the US, we throw almost 88,000 tons of plastic each day. Recycling is not a sustainable solution. The real name for that process is downcycling, because a plastic bottle can never be a 100% plastic bottle again, unlike a glass bottle or an aluminum can. Plastic pieces in the ocean now outnumber sea life 6 to 1, which translates into 46,000 of plastic pieces per square mile. This has caused a toxic food chain contamination through biomagnification. Study shows that 93% of all Americans have plastic in their bodies in the form of BPA, which is linked to cardiovascular disease, breast, brain, and prostate cancer, attention-related disorders, erectile or sexual dysfunction, and many others diseases. Oxo-biodegradable additives mask the problem. It only biodegrades itself and not the fossil-based polymer treated, which stays in the nature as a microplastic form. On the other hand, bio-based plastics either require an unsustainable food source like cornstarch or sugar, or have to modify very significantly the plastic industrial production system just to end up with a bio-based labeled product, which almost always is not necessarily a biodegradable product. Our technology, on the other hand, uses a chemical process called solvation, which is the only legal, safe, practical, and feasible way to destroy fossil-based plastics at a molecular level. Our encapsulated additive targets the links between the polymer chain and dissolves the molecule from the inside out, ending with a wax-like biodegradable carbon-based component like paraffin. For the first time ever, we can truly get rid of plastic and its unintended side effects. The time frame for the dissolvent process can be selected, giving our clients the ability to program their products' obsolescence. Our technology is patented and it has been scientifically tested between Matrix Innovates and Woodchain Laboratories. Timeplast is simply the future of plastic industry. When a plastic product is treated with our technology, we can safely get rid of these bullet points that I'm going to be showing to you, which are the factors in which environmental concern and human health concern occupy the minds of those who use plastic. So the first one is that plastic never goes away. Plastic is durable and it lasts forever, practically. Yet illogically, 33% of it is used once and then thrown away. Plastic cannot biodegrade. It breaks down into smaller and smaller pieces with that then we eat, and it enters the food chain. Plastic affects human health. Everybody now have seen these studies that show that 93% of all Americans have BPA in their bodies, which this chemical by biomagnification can each generation is going to have a higher toxic levels of plastics in their bodies. Plastic attracts other pollutants. Plastic spoils our groundwater. Plastic piles up in the environment. Plastic threatens wildlife. Plastic costs billions to abate, and plastic poisons our food chains, like I said before. So let's see at the Woods End laboratory study to understand a little bit more of the testing that we've done on our technology. First, like the report says, the test was performed on polypropylene and polyethylene. which are the most used and common fossil-based plastics. The standardized test performed is called GB21, which is an anaerobic 69.9 Fahrenheit degrees, which is the most realistic environmental temperature test done to plastics. In contrast, nowadays the so-called biodegradable additives only pass tests at 122 Fahrenheit degrees, which is an unrealistic test. And also most of them are only oxo-biodegradable, which means they will only degrade in presence of oxygen. Okay, let's keep reading the Woodsen laboratory study. Like the report says, the test showed a 36% of weight loss in 32 days in the polypropylene case and a 21% of weight loss in the same period for the polyethylene test. Like the report says, the test showed a quicker biodegradation than cellulose in the first 7 days period. In other words, a fossil-based plastic degraded faster than a natural polymer found in paper. This is truly groundbreaking, especially because we're talking about a fossil-based plastic. The study also shows that the biogas production is indistinguishable from the background noise, but at the same time, a very significant weight loss was achieved. This means something very eccentric and something very important that defines our technology. Our technology doesn't require biodegradation. It doesn't require soil bacteria, water, or oxygen to make the plastic go away. Our additive makes the plastic degrade itself from the inside out. This is called solvation or molecular disintegration. Even if we toss the plastic in outer space, it's gonna be disintegrated. Yeah, this is very important because of the fact that we don't require soil bacteria, water, or oxygen. It means that in any environment, even in outer space, even in deep ocean levels, or even in the seawater, or whatever the place that are plastic, or treated plastic is found, it's gonna disintegrate anyway. I'd like to add that unlike our competitors, our technology disintegrates the plastic no matter where it ends up, even if it's in outer space or on the water, it's gonna dissolve. Our competitors explain. Let me just explain a little bit about our competitors. Most competitors don't even have a patented product, but some of them have a patent. For example, the oxo-biodegradable industry, they have patents like this. And let me quote a highlight on this patent. An oxo-biodegradable additive imparts to them a property whereby they fragment plastic polymers. In other words, but this patent is saying that they only fractures plastics, but the fossil-based plastic still continue to exist in the nature in form of microplastic, which is just a mask for the environmental problem. So one of the questions that people may have about our technology is, can plastic be burned? Because that could be a way. Somebody may think that could be a way to get rid of plastics. But burning plastic can release dioxins, and dioxins are a very known human carcinogen and the most potent synthetic carcinogen ever tested in laboratory animals. This means that it's highly risky to burn plastic, and it is actually illegal to burn plastic. The World Health Organization said that once dioxins have entered the environmental or the human body, they are there to stay due to their uncanny ability to dissolve in fats and to their rock-solid chemical stability. So burning plastic, it's not a feasible way to get rid of plastic. Another question that I might get about the technology is, acids dissolve plastic? Are you using acid as an additive? And the answer is no. For example, one of the strongest acids, the hydrofluoric acid, can dissolve metal, rock, glass, even concrete, but it won't dissolve, for example, polyethylene or polypropylene. It is a well-known scientific fact. And if we would use acid to dissolve plastic, it couldn't be feasible because there's no metal machine who could maintain the chemical structure through that process. The machines would collapse, and for that reason, no industry could function that way. You can always go to timeplast.net, and if you have any question, we would be happy to answer it for you. One of the big questions about our technology is that, is it FDA approved? Given the fact that our additive is not in the food but in contact with food, we need to file an FCS approval for each and specific polymer that we create. Because of the fact too that our additive is tailor-made to target in a specific polymer chain, we need to do that with each and every additive that we're gonna be creating. But the best part about this question is that the same components found on Timeplast have already been approved. This can be seen on the official FDA webpage in the FCS or Food Contact Substance Safe published records. In this case, heptane was published as safe, which is the most synthetic delicate component found in our additive. The rest of the components are found in fruits and other natural sources. Using a plastic or polymer chain to encapsulate a chemical component is the most used way to produce a wide range of plastic products. It has always been safe because of plastic's barrier properties. 120 days after we submit the form, the FDA will or will not respond. If they don't, we will have an approval by law. Showing the approved components used with our technology from other additives published food safety specs is the legal path to pursue in terms of any FDA issue. The extremely low and patented proportion from the active chemicals in the final compound makes our additive the most safe and FDA approvable technology that I've ever seen. Okay, so I give it back to Jorge.
Thank you, Manuel. Okay, what we now have, after the plastic has been totally disintegrated by our additive, is a substance that is no longer plastic, but a wax-like substance which will not harm the environment at all. Okay, as you can see, Manuel is taking it out here. Okay. The demonstration you've just seen is what happens to plastic after its desired use. What we have left here is 100% carbon-based, biodegradable, benign subproduct without any trace of its original plastic state. Okay, at this point, we encourage you to feel free to ask any questions. You can simply visit us at timeplast.net, and Manuel will be happy to answer any questions you may have. Thank you very much for taking the time to look through our presentation and our demonstration.